Hi everyone, welcome back to our science class. My name is Teacher Yuri, and in today's video we are going to study one of the properties of sound, which is loudness. Okay, so I want you to please get your student's book. This is inside out, primary 5. This is how it looks, and then open it on page 128. Okay, this is this one. So this is what we are going to study about today. So it is all about the loudness of sound. All right, so when you have your books ready and you are now on page 128, let us begin learning our topic for today. Alright, so as I have said, what we're going to study today is about the properties of sound, in particular loudness. Okay, so let's begin. So the loudness of sound, it actually tells us how loud or soft a sound is. Okay, so depending on the source of sound, it can be soft, it can be loud. So that is loudness. Now let's say, for example, when we are talking to our classmates, when we are talking to our mom or our dad, our sound, the sound that we produce is actually a soft sound. Okay, so we do not need to exert a lot more energy to create a louder sound because it is unnecessary, because we are just talking to the person in front of us, or we are just talking to one person. Whereas when we are going to talk, for example, in front of us, on top of the stage, for example, in a conference, or we are going to talk in large crowds, so we have to have a louder sound. We have to produce a louder sound so that we will be able to be heard. Okay. So loudness, some sounds are soft while others are loud. The loudness of a sound depends on the size of the vibration. Okay, so how loud or soft the sound is, it will depend on how big or small the size of the vibration is. So small vibrations produce soft sounds, while large vibrations actually produce loud sounds. So the larger the vibration, the louder the sound it produces. Now, the louder sound, the greater the amount of energy it carries. A sound moves further away from its source, its energy spreads out over a wider area. So remember, before we have discussed that the energy of a sound actually depreciates as it goes further from the source of the sound. So that is the reason why you can hear it louder when you are near the sound, while it is softer, or it becomes inaudible, or you cannot hear it anymore as you go further from the sound. So the sound, how loud the sound is, it depends on the amplitude. So the larger the amplitude, the louder the sound. Okay, so the smaller the amplitude, it is also creating softer sound. So the size of vibration is called the amplitude. Okay, let's see, for example, this one. The source of our sound is the drum. Okay, but when we tap the drum softly, or we do not exert a lot of energy in tapping the drum, it will create a low amplitude. So lower amplitude means that the sound is softer. Okay, so it also depends on the energy that we exert in creating the sound, whether it will create a larger or soft sound. So when we tap it gently, it creates low amplitude, which means that the sound is softer. Whereas on our second example, when we tap it harder, okay, when we tap the drums harder, then it will create larger amplitude. It means that we also exert larger amount of energy to tap the drums, and then it creates larger amplitude, which means that the sound it produced is a loud sound. So the amplitude of sound waves determines the loudness of sound. So the size of the vibration is known as amplitude, and we use a sound level meter to measure the amplitudes in decibels. So the the apparatus that we use to measure the loudness of sound or measure the amplitudes of the sound is sound level meter. Okay, and the unit of loudness of sound is called decibels. Okay, so for example, 61.1 decibels, that is how loud the sound is. Okay, it measures the amplitudes, which determines how loud the sound that is being produced. So what is the difference between pitch and loudness of sound? So the pitch of sound depends upon the frequency, okay, while the loudness of a sound depends upon its amplitude. So the frequency of the vibration is determines how high or how low the sound is, while the amplitude or the size of vibration determines how loud or how soft the sound that we produce. For example, this one, we have both sounds, and you can notice that they have the same frequency. Okay, right here, they have the same amount of frequency, so it means that they have the same pitch. Okay, they are different perhaps with the amplitude, because both sounds have different size of the amplitude or the size of vibration. So the other one has greater amplitude, and this next one has smaller amplitude, which means that the first sound is actually louder than the second one. So, can a human being hear every sound that is produced? Audible frequency range is only from 20 hertz to 20,000 hertz. Okay, so we cannot be able to hear sounds more than that. And then 20 hertz and beyond is an ultrasound, and then lower than 20 hertz is an infrasound. Okay, so there are certain animals that can hear ultrasounds, such as cows, dogs, and horses, while infrasound, an elephant can hear those. So, but human beings can only hear sounds from 20 hertz to 20,000 hertz. Okay, so right now let us go to your exercise for the day. So we have your exercise is going to be on page 87 of your workbook. So we are going to answer just 5 questions. 3 of those we will answer together, where the rest of the questions you are going to answer by yourself. Okay, so let's begin. So this is once again on page 87 of your workbook. So number 1, what does sound level meter measure. Okay, so what do you think does sound level meter measure? So we have discussed this just about now. So letter A, is it the volume of a sound? Letter B, is it the pitch of a sound? Letter C, is it the distance from a sound source? Or letter D, is it the area where a sound can be heard? So what do you think is the best answer? Is it the volume, how loud or how quiet or soft the sound is? Or letter B, is it about how high or how low the sound that is produced? Or letter C, is it the distance from where the sound is coming from? Or letter G, is it the area where a sound can be heard? So what do you think is the correct answer? Alright, so let's think about that. So perhaps we have letter A. It is measuring the volume of the sound. It means that how loud or how soft the sound is, or it measures how large or how small the amplitudes are. Okay, so number one, the answer would be letter A. Number two, sounds cannot travel through blank. Okay, so although this, I think we have studied this one last week or last week, but this topic is quite very important when we have studied about the properties of sound, or how sound travels. So sound cannot travel through letter A, a wooden table, that means to a solid. Or letter B, water. Can you not hear anything when you are underwater? Or letter C, air. Can we not hear anything when we are surrounded with just the air particles? Or letter D, the vacuum. Okay, so the answer would be letter D, vacuum, because before we have discussed that there are no particles or molecules where sound can travel through in a vacuum. It is an empty space. Okay, it cannot travel through the particles of solid, it cannot travel through particles of liquid, it cannot travel through the particles of gas. So vacuum is an empty space. So whether you create a very loud sound in a vacuum, it cannot travel. The vibration cannot travel. Okay, so let's go to the third one. Which of the following is false? False means it is not correct. Letter A, sound is a form of energy. Letter B, sound is produced only when it bounces off a surface. Or letter C, sound is caused by vibration of objects. Or letter D, we hear a sound when the vibrations of air reaches our ears. Okay, so which do you think is not true? Now letter A, sound is a form of energy, isn't it? Yes, it is a form of energy caused by the vibration of objects. Letter B, sound is produced only when it bounces off a surface. Okay, so do we hear a sound only when it bounces off any surfaces, or it bounces off walls, it bounces off solid objects, stuff like that? Is it correct? Or letter C, sound is caused by vibration of objects. So letter C is actually correct, because sound is caused by vibration. So basically, without vibration of objects, there will be no creation of sound. Okay, so let's go to letter D. We hear a sound when the vibrations of air reach our ears. Is it correct? I think it is correct, because, for example, we are talking to our friends. The only medium that we have in between us and our friends is the air. So when the vibrations of in the air reaches our ears, we can actually hear the sound. So our correct answer would be letter B. Letter B is false because sound is produced when there is vibration. Okay, so the next two questions, questions number 4 and 5, you're going to answer that by yourself. So please read question number 4 and try to select the best answer and write them on the box provided, and also number 5. So I hope you have learned something from our lesson for today. My name is Teacher Yuri and I will see you on our next lesson.